Hello everyone. In this video we will understand how to use Kubernetes deployments to run stateless workload, and we will understand how to manage application updates and rollouts. First of all, we will understand what is Kubernetes deployment. Deployment is a higher level abstraction than replica set and uses replica set to control underlying pods or to control child pods. So deployment manages a set of pods to run stateless workload. Deployments are normally used to run stateless workload. Deployment object creates a replica set to manage pod replicas. So when we create deployment, a replica set is created automatically, which is used by deployment to manage underlying pods. Deployments provide features for rolling updates and auto-scaling. And because of these additional features, we need deployments. Deployments support declarative updates for its pods and replica set. So it means we can update deployment using declarative approach, and the changes made are reflected in the replica set and the child pods. Now let's move to the control plane node and understand how rolling updates and fallbacks work practically. Now we are on control plane node and I am logged in as KTS user. And I can access Kubernetes cluster using kubectl client. And for this lecture, we need this file. I will display this file. And in this file, we have two objects specified. And this is a configuration to create namespace. And we will create namespace with this name. And this is a configuration to create deployment. This is exactly same as we used for replica set, but we are using different label and we are using different name and we are creating the deployment in this namespace. Under the spec, like replica set, deployment also has three high-level fields: replicas, selector, and template. And we already talked about these fields. And here we are using same pod template. Now I will clear the screen and we will create this deployment. kubectl apply with -f option, then the file name. So namespace with this name has been created and deployment has been created. Now we will list objects in this namespace. kubectl -n to specify namespace, or you can always use -- namespace long option. The namespace name. Get all. So in this case, we have deployment object, replica set object, and of course pods. And we know when we create deployment, replica set is created automatically and is used by deployment to manage child pods or dependent pods. Now we will display deployment object configuration in YAML format. kubectl then -n to specify namespace name, get deployment, then deployment name, -o to provide output format. So this is deployment configuration in YAML format. And we know API version in this case is apps/v1. Kind is of course deployment. Then under metadata we have annotations, and last applied configuration is stored as a part of annotations. And this field specifies revision. We will talk about this field soon. Then we have labels, and these are the labels for the deployment. and they have nothing to do with the labels on the ports. Then we have name of the deployment, namespace, and other fields we discussed already. Important here is to discuss spec. Under the spec, we see few different fields. For example, revision history limit. This is set to 10. This field is related to rolling updates. When we roll out update using deployment, a new replica set is created to create ports with the new configuration. And this field defines how many replica sets in total are kept, which are created as a result of rolling update operations. And why we need to keep them? We need to keep them in case we need to perform rollback. In that case, deployment uses specific replica set to create ports for the specific revision. It will be more clear later. Then again, we have selector and we have template, and under status we have available replicas and also ready replicas, and replicas field. We already talked about this. And under conditions we have information about deployment related transitions. Now important here is this field, strategy. This defines strategy for the rolling update. Under rolling update object, we have two key value pairs defining max search and max unavailable. Now we will understand role of these fields. When we trigger rolling update for the deployment, these fields play an important role in performing rolling update in controlled way. Now we will understand how it works. This field, max search, which is set to 25%, which is the default value, allows deployment to create extra ports over desired ports during rolling update to maintain availability. For example, for a deployment with 2 replicas, 25% of 2 will be 0.5, and this count is rounded up. So it means it will be considered as 1. So during rolling update, deployment is allowed to create an extra port to maintain availability. Now we will talk about other field. And this field, max unavailable, which is set to 25%, defines number of ports which can be unavailable during update, and this value is rounded down. Again, we will take example of 2 replicas and value will be 0.5. So maximum 0 port can become unavailable during update. So it means desired port replicas count should be maintained during rolling update. So deployment has to respect both of these fields. Deployment would create one extra port for the rolling update, and when this port will be available, only then one of the 2 old ports will be deleted, because it also has to respect this field. So in one line, in case of 2 replicas, deployment can create one extra port as allowed by this field, and to respect this field, deployment must not delete any port until this new port becomes available. So this is done to maintain availability of application, and we can always change these values as per our requirements. Now I will clear the screen. Now we will display replica set object, and we need this command. Now in this case, owner of replica set is the deployment, and the name of replica set is deployment name, then random string in the end. We will scroll up. Here we will talk about annotations and the owner references. Rest everything is same, and we already talked about this. Under annotations, we have this field specifying desired replicas, and we know count is 2, and this field specifies max replicas, which is set to 3. This is because of max search field, and we know how this works. And this field specifies revision for the deployment. Still we did not do any rolling update, so we have only one revision. Now about owner references, and we know in this case owner is deployment, and we have this information about deployment object. Now we will clear the screen. Now we will understand how rolling update works. But before that, I will display rollout history for the deployment. And for this, we need to use kubectl then -n to specify namespace rollout history for the deployment, then the deployment name. And we have one revision on the list, but there is no change cause specified. But setting this helps in rolling update. So now we will set this, and for this we need to use annotations. To set annotations, we will use kubectl then namespace annotate deployment, because we need to annotate deployment. Then the deployment name, here we need to provide annotation to be set, and in this case we need this field kubernetes.io/change-cause, and here we need to provide information about image we are using, and we used latest nginx image, so we will set this value. So we are done. Now again we will display rollout history, and we need this command. Now we see some additional information, and it helps when you perform rolling update. Now we will trigger rolling update by updating image in deployment. But before that I will list ports in the namespace. And we have 2 ports running in this namespace. I will scale up this deployment to replicas count 4, so we can see progress of rolling update, because with 2 ports it will go very fast. kubectl then namespace scale deployment, then deployment name, and we need to provide replicas count 4. Now we can see 2 more ports are being created, so they are running. Now we will use kubectl set command line to set new image. kubectl then the namespace set image. We need to set image. I will display help kubectl set image, then we need to provide deployment, then deployment name, then we need to provide container name. So first we need to check container name. kubectl -n namespace name get deployment name -o YAML. So container name is nginx. Now we will use kubectl set. kubectl -n namespace set image deployment name, then the container name and the new image to be set, and we will use nginx :1.14.2. We will use this specific version. I will hit enter. Now I will list ports and I will use -w flag. But rollout has already completed. We can use -w or -- watch to watch resource changes using Kubernetes API, and it's very useful for slow applications or for heavy applications which take more time during update. So instead of listing ports again and again to check the status, we can use this flag with this command to watch the changes happening in real time. Now we will display rollout history. And we know for this we need this command. So now we have one more revision, but we have same change cause, and this is taken from the annotations. So now we must update annotations, and we know how we can do this, and we need this command, and here we will provide version information. So we are using this version. So we are done. Again, we will display rollout history. Now we have two revisions, and this is the previous revision using latest nginx image, and this is the current revision which is running now. Now I will list all the objects in the namespace, and we need this command. Now here this is important. We have two replica sets. This is because of rolling update, and at this moment this replica set is in use, and this is the replica set containing old configuration. So in case we need to perform rollback, this replica set will be used to roll out ports, and we know this replica set contains old configuration. Now we will verify same. kubectl namespace get replica set. First we will check current replica set, and we will display configuration in YAML format. We need to check image, and we have this image. Now we will check other replica set, and here we have latest nginx image. If we don't specify any version, latest tag is used. This is how deployment uses replica set to manage rolling updates. Now we will perform rollback, but again I will display rollout history. To perform rollback, we need to use kubectl, and of course we need to provide namespace kubectl-n namespace rollout undo. So it means we want to undo recent rollout, then deployment name. On execution, it will fall back to this revision. So a new revision with number 3 will be created with the same configuration as that of revision 1, but revision 1 will be removed from the list. Now we are done. We'll execute get command, and again rollout is already completed, so we could not see the effect of this option. Now I will display rollout history. Now here we see new revision on the list, and we know this is using latest nginx image, and the revision 1 has been removed. Now we will update the image to version 1.16.1. But before doing so, I will keep this command ready so we can watch changes. Now again we will use kubectl set command line, and we need this command. I will hit enter. Now here we can see the progress. it will be updated in real time. So we can see the progress. I will clear the screen. Again, we will list the pods. 4 pods are running as expected. Now we will display rollout history. And we need this command. And now we have new revision on the list. And we know now we need to update change course for this. And we know how we can do this. We need this command. I will execute. Now again we will display rollout history. So now we have 3 revisions. And this is the latest one and which is in use. We already understood how to do fallback. Fallback means fallback to previous state. And previous state in this case is revision 3. But we need to fall back to this revision. Now we will understand how we can roll back to a specific revision. So we need to use this command. Everything is same. If we execute this command without this flag, it will roll back to this revision. But we can specify revision we want to fall back. So now it will fall back to revision 2. So we are done. So pods are already running. I will clear the screen. I will display history. Now we see revision 2 has been removed and we have new revision which is same as 2 and is using this nginx image. This is how we manage rolling updates with deployments. Let's assume in some environment you don't have this information. In that case, you can display information specific to revision using same command but using a specific flag. And we know we use this command to display rollout history. But we can use this flag to display information about specific revision. For example, 5. And here we can verify which image is in use. This is all about this lecture.